Welcome back to the SAT Math 800 Challenge series. Today's problem is about circles. Pause the video now and see if you can solve it on your own before watching the solution. When you're ready, we'll first solve the problem algebraically, and I'll show you an alternative approach using Desmos that's especially useful for the digital SAT. Before we begin, let's quickly review the equation of a circle. The standard form of a circle is x minus h squared plus y minus k squared is equal to r squared. In this equation, the point hk is the center of the circle and r is its radius. Notice that right-hand side is not the radius itself. It is the square of the radius r squared. Here's today's challenge. We are given two circles with the same center. The area between them is 3 times the area of a smaller circle. Our goal is to find the value of c in the equation of the larger circle. Since the equation is given in general form, let's first find the center and the radius of the circle M. For circle M, we need to put it in standard form to find the center and radius. So let's put the x variables next to each other and y variables next to each other. X squared minus 8x plus y squared plus 12y is equal to 12. We need to complete the square. Half of 8 is 4. We're going to add 4 squared on both sides. Half of 12 is 6. We're going to add 6 squared on both sides. Let's factor x squared minus 8x plus 4 squared. It's a perfect square trinomial. It's going to be x minus 4 squared. We can also factor y squared plus 12y plus 6 squared, which is y plus 6 squared. On the right, 12 plus 16 plus 36. 12 plus 16 is 28. 28 plus 36 is 64. Now we have the equation in standard form, and we can find center and radius. The center is 4, positive 4, negative 6. And radius is square root of 64, which is 8. Since r squared is 64, the area of circle M is 64 pi. Now let's see how Desmos can help us find the center and radius of the original circle without completing the square. Enter the original equation. Desmos grabs the circle automatically. To find the center, we can use the highest and the lowest point of the circle. Click on the highest point of the circle. Desmos shows that highest point is 4 and 2. Let's call this point A. Now click on the lowest point of the circle. Desmos shows that the lowest point is 4, negative 14. Let's call this point B. These 2 points are the endpoints of a vertical diameter. The center of a circle is a midpoint of any diameter. In Desmos, enter midpoint. A and B. Desmos gives 4 and negative 6. Therefore, the center of a circle is 4 and negative 6. This matches the center we found by completing the square. Now we need a radius. The radius is a vertical distance from the center to the highest point. The highest point has y coordinate of 2 and center has y coordinate -6. Therefore, r equals 2 minus -6, which is 8. So r squared is 64. Circle N has the same center as a circle M and a larger radius. Now, let's carefully interpret the most important sentence in the problem. The area of a region inside circle N but outside circle M is 3 times the area of a circle M. This shaded outer region is not the entire area of circle N. It's the difference between the two areas. Therefore, area over circle N minus area over circle M is equal to 3 times area over circle M. Adding AM to both sides gives area of circle N is equal to 4 times area of circle M. From the previous step, the area of circle M is 64 pi. Now substitute this into the equation. 4 times 64 pi, which is 256 pi. The area of circle N is of the form pi r n squared. Dividing both sides by pi gives r n squared equals 256. Circle N has the same center as a circle M. Its equation in standard form is x minus 4 squared y plus 6 squared is equal to 256. We have the equation of a circle N in standard form. X minus 4 squared plus y plus 6 squared is equal to 256. However, the question asks for the equation in the form x squared plus y squared plus ax plus by is equal to c. We need to expand the equation. X minus 4 squared is x minus 4 times x minus 4, so x squared minus 8x plus 16. Y plus 6 squared is y squared plus 12y plus 36 is equal to 256. Let's rearrange this. X squared plus y squared minus 8x plus 12y. 16 plus 36 is 52. On the right, 256. Subtract 52 from both sides. X squared plus y squared minus 8x plus 12y is equal to 204. Therefore, the value of C is 204, choice B. Today, we covered 3 important SAT math skills: finding the center and the radius circle, using radial relationships, and writing a circle equation in general form. Thanks for watching, and I'll see you in the next SAT Math 800 challenge.